Hello students, in last video we have seen the critical section problem. Clear? So now for this problem, what are the solutions? Okay, so there are three solutions to a critical section problem. One is Peterson's solution. Okay, so this is the solution of critical section problem. So now we will see what is this Peterson's solution. Clear? So now a Peterson's solution is a software based solution. Okay, a classic software based solution to the critical section problem is nothing but a Peterson's solution. So now this Peterson's solution, so it is only for two processes which alternate the execution between then critical section and the remainder section. Means what? It allows only a two processes. Okay, or you can say it is limited only for a two processes. So now as you can see on a screen, Peterson's solution is restricted to only a two processes, that is going to change the execution between the critical section and the remainder section. So I hope you remember the critical section problem. So in that I have explained in detail what is entry section, remainder section and exit section. Clear? So now in Peterson's solution we are going to use the two data items, or you can say two variables which are going to be shared between the two bases, two processes, you can say, that is turn and the flag. So that turn is a variable declared in the data type integer, and the flag is a it is an array of type boolean. Clear? So now what is the use of this turn variable? So the turn variable indicates whose turn it is to enter its critical section. So CS is nothing but a critical section here. Suppose if there are two processes are running, so in that which process is going to enter in the critical section. So the turn is a variable used to indicate whose turn it is to enter its critical section, or you can say the turn it indicates who should enter in the critical section. So again one more variable I told, a flag array, or you can say a flag is an array of type boolean. Okay, so boolean is nothing but a 0 or 1, or you can say a true or false. Clear? So now the flag array is used to indicate if a process is, or you can say whether that process is whether that process is interested to enter in its critical section. Clear? So the flag array is used to indicate if a process is ready, whether that process is ready to enter in its critical section. Clear? So these are the two important variables we are going to use in the Peterson's solution, and you need to remember that what is the purpose of those variables. So turn indicates here the whose turn it is to enter in its critical section, and similarly flag array. So flag array is used to indicate whether that process is ready to enter in its critical section. So now we will see the algorithm of the Peterson's solution. So as you can see here, so again whatever I told the variables, those variables we are going to use here. So flag I is equals to true. Okay, so when I is what now here? So I as I told, a flag is a what array it is. Okay, of type boolean. So the value here it will be 0 or 1. So if flag 0 is equals to true, then it is going to set into then it sets the turn to j. So j is what now? 1. Okay, so why j is equals to 1 now? For example, if we are running here the processes p0 and p1. So for p0, as you might be you know that here the array index or the index will start from always 0. Okay, so for p0 process for p0 process the position of that array is nothing but a 0. So hence if I set the first process as a first process as a flag 0 is equals to true, then which turn we are going to, which turn it is to enter in its critical section, that is turn j. So turn j is nothing but, for example, process P1. So then process P1 is going to enter in its critical section. So for example, when flag is equals to 1 for process P1 and for flag 1 is equals to true, then the process P1 goes to the critical section. Okay. When just you remember here that flag value, if it is 0 then if it is true, and if turn is equals to when if again turn is equals to 0, then that time we are going to set the P0 process, P0. So 0, P0 process is going to enter in its critical section. Okay. And when flag 1 is equals to true and again turn is equals to 1, again in that same condition we are going to enter, it will enter into its P1 is going to enter in its critical section. So if P0 and P1 tries to execute, okay, if both the processes are going to execute at the same time, so then that time you need to check this condition, that is while flag of j and turn is equals to j. Okay. So for example here, while flag of j and turn is equals to j, if P0 and P1 tries to execute at the same time, then the turn is going to first change it to I. Okay. And then j or it could be vice versa. Only one of these two processes is going to be allowed to enter in its critical section. It means what here, while flag of j, suppose j is a 0, flag of 0 and turn is again equals to 0. Okay. So until and unless it has to become true, then only it is going to enter in its critical section. So now if flag of I is equals to false, then it is going to execute the remaining code segment, you can say, or you can say one I have explained in the next slide, that in that diagram the entry and exit sections you need to remember that are enclosed in the boxes. In the entry section, process I first raises a flag, that is flag of I is equals to true. Process I first raises a flag indicating the decide to enter the critical section. So now we need to set a turn value to a j. So why we are setting the turn value to j? Because it is going to allow the other process to enter the critical section. It means what here, you just remember here that whenever the flag of I is equals to true, we are giving the permission to some other process, or as I told, turn indicates who should enter in its critical section. So we are giving us some other chance to some other process to enter in its critical section. So now the while loop, as I told, the while loop is a busy loop because it is an infinite loop. Okay, as you may notice there, we have written the semicolon. So which makes process I must wait here. The process flag, the while loop is a busy loop, which makes process I wait as long as process j has the turn and wants to enter the critical section. So process I is going to decrease the value of flag of I in the exit section, allowing process j to continue if it has been waiting. It means what? For example, if P1 starts first, then entry section function for P0 will be called and values will be that I have mentioned there. Interested, flag of I is equals to true, that is nothing but interested. So if that process is interested, then we are going to set the turn 0, then while if that interested process is equals to true and again the turn is equals to 0, so in that this while condition will be false, as interested of 1 false and turn is equals to, and process will enter in its critical section. So now just go through the algorithm, just put the values of I and j. So I, if you take 0 and j will be 1. So if that's so, then it is going to enter in its critical section. Otherwise, if flag value is a false, then it is going to execute its reminder section of a code. So now again it preserves all the three conditions: mutual exclusion, progress, and the bounded waiting. So mutual exclusion, so as you know that only one process can access the critical section at a time, then progress is also assured as a process outside the critical section does not block uh, their processes from entering the critical section. Means what? Progress is also as a process outside the critical section does not block other processes from entering the critical section. So now what is bounded waiting? So bounded waiting is preserved as every process gets a fair chance. Means as I told in the last video, that is critical section, bounded waiting means suppose P1 is executing and P2 is waiting. So P2 is going to wait for how much time? Not infinitely it should wait. So bounded is nothing but there is a limitation for waiting. That is nothing but this. Okay, so now what are the disadvantages of Peterson's solution? So as I told, only two processes are running. It is limited only for two processes. And one more is okay, that is the first disadvantage. Peterson's only works for two processes, and it is actually best in the user mode. So user mode and the kernel modes we have studied, okay, two modes of operating system. So again this solution is also a busy waiting. Okay, why? Because if one process is executing in its critical section, the another process must wait here. So this solution is also a busy waiting. So if waiting for a certain time or more time, so the CPU time is going to be wasted. So that problem is nothing but a spin lock. If the particular process is waiting for a longer time, that problem is nothing but a spin lock. So why it is a spin lock? Because in a loop, a thread is nothing but if the number of processes are waiting, simply spins means nothing but it just simply waiting for the CPU. If it is available, then it is going to enter in its critical section. So checks repeatedly until the lock is becomes available. So what is lock now here? What is lock? If already one process is running in the critical section, we say it is a locked. That critical section has been locked for that specific process. So if another process should enter in its critical section, then that lock should be released or unlocked, you may say. So now this type of lock is nothing but a spin lock. Okay, the lock is nothing but a busy waiting, you can say. And one more disadvantage of Peterson's solution is it does not support for the modern architecture of computer. Means you can say modern architecture of computer means Intel i3, i5, like this, new architectures of Intel, Pentium, you can say. Okay, thank you.